3, we're told to sort this thing out here. Okay, so we've got 4 cos x plus 2 sine x equals 3. Okay, so the first thing we're going to do, I'm going to go and write that. We know we can write that in the form of r sine x plus or minus alpha, or r cos x plus or minus alpha. Now I'd be looking here at the one that I'm going to get to help me the most. So sine and cos here, I've got to choose which, and you can actually write it in either, it doesn't matter. And I can tell you now what r is going to be. Can anyone tell me what r is going to be? Yeah, it's be root 20, very good. It's always that squared plus that squared, then square rooted. So you can work out r very, very simply. Forgetting the plus 3 for now, okay? We're going to deal with 4 cos x plus 2 sine x, and we're going to deal with it as r, and it's going to be either sine or cos there. Now, I've got a plus there, and I've got it in terms of cos, then plus terms of sine. So I'm having a look here, which I think is fine. Either of these is fine, okay? But because it's a plus there in the middle, I want this to have a plus in it, so I either choose the sine, where I'm choosing the top one, so I'm going to choose the top one there, so it'll be a plus, or if I choose the cos, it's going to be a plus, so I'd have to have a minus in the middle. It doesn't matter which one. Any thoughts? Anyone want to go with a particular type here? I'm going to go with sine then in that case, because plus and plus just makes things a bit simpler, okay? So we're going to say that is r sine, and then plus there, so it's going to be x plus alpha. Okay? All good? Now I'm going to write out a bracket here where I'm actually going to run that through double angle formulae, okay? Which is a little bit of overkill. You don't necessarily need to do this, and you're actually very good at doing shortcuts in this. And if you're confident doing a shortcut, that's fine, but I'm going to show the proper method, okay? So sine x plus alpha. Now I'm using the sine one, so it's going to be sine a cos b plus cos a sine b. So that is going to be sine a, so that's sine x in this case for me, and then cos b. So our b is actually an alpha, so it'd be cos alpha. Yeah? And then plus, because we chose a plus there, we'd have to choose a plus one there, you're just following the top there. And then it's going to be cos a, so that's going to be cos x, and then sine alpha. All good? So that is then going to be r sine x cos alpha plus r cos x sine alpha, which is this 4 cos x plus 2 sine x. Okay? Now, effectively here, we've got a 4 cos x, and we've got something here which is something cos x plus sine alpha. And then here we've got something with sine x. And here we've got something with sine x in it as well. Joe? Of course you can. So what I'm going to do now is create 2 equations from that. That if I'm saying something cos x plus something sine x is equal to something cos x plus something sine x, basically you just take the cos out of each of those and you say 4 is equal to r sine alpha. And then my second equation would be 2 is equal to r cos alpha. Okay? Now from there, that's how Elliot has technically gone and worked out what r is already. He's done 1 squared plus 2 squared, which is really going to be 4 squared plus 2 squared is equal to r squared sine squared alpha plus r squared cos squared alpha. You don't need to show all this though. As long as you put the answers in, it's fine, and we already know it's root 20. That's going to be 16 plus 4 equals r squared sine squared alpha plus cos squared alpha. What do you know about what about sine squared and cos squared? 1 r squared times by 1 r squared. So then 20 is equal to the root of r. Sorry, root of 20 is equal to r. That's what I meant to say. The other bit, we want to use something from C2 here. Any idea how we're going to manipulate these formulae? Divide, yeah. So we're going to do 1 divided by 2 or 2 divided by 1? Why? So it gives you tan. Okay, so 1 divided by 2 is going to give 4 divided by 2, which is 2, is equal to r divided by r, cancels, sine alpha divided by cos alpha, tan alpha. Just so I stop myself putting 2 equals on one line. Take the tan over to the other side. Tan to the minus 1 of 2 is equal to alpha. So alpha is 63.38. 63.4 is it? Yeah, lovely. The same. You see that? 63.4. Now, one of the things that you did, can you remember I showed you, I did like a lesson and said, look, there's a real big shortcut to this. We've got to be good at doing the shortcut because it saves loads of time. This is sort of question that can throw a bit of a red herring, but also one of the things that you told me, I think it was Aaron, I remember him saying, oh, in fact, actually loads of you picked this up much quicker than I did. If I use the sign there, you said to work out the thing, it's always going to be the r squared to the root 20, which Elliot told us like that. But because we use sine, you said you always do the one that you're not using, so cos divided by sine, so you just do 4 divided by 2. It would have been tan to the minus 1 of 4 divided by 2. Again, a shortcut, if you remember it. If you don't, you'll just have to run through this. It's doable, it's just fussy, isn't it? So we can then say, therefore, and we can change this line here to what we've just found. So root 20 sine, and then x plus alpha, no, x plus 63.4 is equal to 3. Now from there, we'd want to do, hey miss, everything okay? She's not on a trip today. Lovely. With the next bit now, we were basically solving this equation. This is like a C2 equation, but just sort of like on steroids. It's a bit harder than what we get at C2. So we're going to get sine of x plus 63.4 is equal to 3 over root 20. We're then going to take the sine over, leaving x plus 63.4 is equal to 42.1. But remember, you're all silly tomcats. 3 over 20 is positive divided by positive, so it'll be a positive. So all in sine, 42.1, 42.1. So I need to do 180 minus ands to give me 137.9. Now, bear in mind, we're going to take away 63.4 off each of these, and it wants my range in the question between 0 and 360, I think it said. Yeah. So I need to go and find the next answer here. So what do I do to that? Find the next answer? Add 360. So if I get that answer back, I just press equals in the calculator, plus 360. 402.1. And then, it's when you sign a number. When you sign a number, that's when it generates all of these numbers here, and that's why you find this stage here. And then you take 63.4 off all of those. That's going to be a waste of time. I'm just going to cross that out because it's not in my range. So 137.9, take away 63.4 is 74.5. And then 402.1, take away 63.4 is 338.7. How can I check that? Because I can leave this exam having a good idea if I'm right here. Put it into the calculation. If you come and look back at the calculation, where was it, number 3? I'm saying x is either one of these values here, so I've got that in my calculator as ands, so I'll use that as ands. So I'm going to do 4 cos ands, and then plus 2 sin ands. And that answer should be, roughly speaking, when I press equals, what? Should be 3. Look at that. What a lovely feeling. Yeah? You're in an exam going, ooh, I've just nailed 7 marks. Aren't we? Yeah. Yes.